Hello and welcome to Maths by SAS. This is my second lesson of D1 chapter number 1 exercise 1A, that is about the prime and composite numbers. In this class, students will be learning and discussing basic level question number 3 C part, and question 3 says find each of the following by using the prime factorization. In the previous class, we learned how to find the square root of the given numbers by using prime factorization, and in this class, students, we will be learning how to find the cube root of the given numbers by using prime factorization. And as the question is saying to go for the prime factorization, so it's really important to understand the meaning of term factor, factorization, and prime factorization and prime factors. So let's begin the class with the question that what are the factors? Recall my previous lesson that factors are the numbers that when we multiply together we get the number back. Like let me give you the idea that if we say that 2 and 3 are the factors of 6, and when I'm multiplying 2 with 3, I'm getting 6 back. And then factorization is the process of expressing the number as the product of its factors, and prime factorization means to express the number as the product of its prime factors. And then we should have good command on the index notation as well. So for index notation, the repeated factors have to be written in short form. So let's move to today's class. So first of all, we have to make the prime factorization of the given numbers, and for that purpose what we have to do, we should have good command on the divisibility test as well, because in O-level examination we will not be having long time in deciding that how to divide the numbers. So before going to the your O-level examination, you should have good command on divisibility test as well. And if you find any difficulty in understanding the divisibility test, watch the lesson that is given. Link will be given in the description box. 3375. So this number from the very beginning will not be divisible by 2 because the unit digit is 5, which is not the multiple of 2. Let's test 3. Okay, and for the divisibility test of 3, what we have to do, we have to add up the digits of the number which are given in the question. 7 plus 5. 7 plus 5 is 12. 12 plus 3 is 15. 15 plus 3 is 18. 18 is divisible by 3, so this whole number will be divisible by 3. So let's give a try. 3 ones are 3 ones are 3 twos are 6. 1 will be given to 5 and 3 fives are. Again 5 plus 2 7 plus 1 8 plus 1 9. As the sum of the digits is divisible by 3, so this 1125 will also be divisible by 3. 3 how many times 11 or closer to 11? 3 3s are 9, and then 3 7s are 21 and 3 5s are. Again 7 and 3 10. 10 plus 5 15. So we can divide this number by 3. Okay, 3 how many times? 3 ones are 3 ones are, and then 3 twos are 6 and 3 fives are. Now okay, 5 plus 2 7 plus 1 8. We cannot divide this number by 3, but as the unit digit is 5, so we can easily divide this number by 5. 5 twos are 10, and then 2 will be given to 5. 5 fives are, and then again 5 fives are and 5 ones are. So first what we have to do is that we have to write 3375 as the product of its prime factors. So this is 3 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5 multiplied by 5 multiplied by 1. Now we can write this in form of the index notation, that this is 3 cube multiplied by 5 cube. And now this is not the requirement of the question. The requirement of the question is that we have to find the cube root. Okay, what to read? Cube root of this. So I will be putting the cube root symbol on both sides. And now look, now for the calculation purpose, I have to write this in form of the fraction, 5 raised to power 3 whole 1 by 3. And now you can see, students, that both the factors or all the factors of this number are having the same index 3 at the top. So what we can do is we can extract that as a common factor. 3 multiplied by 5 raised to power of 3 multiplied by 1 by 3. This goes with this, and this will become 15. So 15 is the number, cubic root of 3,375 is 15. You can see, students, that if the number is a perfect cube, when the number is a perfect cube, the index of each of the prime factor of that number must be either 3 or multiple of 3, so that we can easily simplify that with the outside index. Moving to the second part, that is the cube root of 1728. So first of all, we have to go for the prime factorization of 1728. Okay, so let me draw the diagram here for division purpose. Okay, 1728, and in the meanwhile you have to go and think that which smallest prime number will be suitable for 1728, as the unit digit is 8, which is even. So we can easily divide this number by 2. So 2, how many times is 17, or closer to 17? 2 8s are 2 8s are, then 1 will be given to this number, 2 6s are, and 2 4s are. And again, what we have to do is that we have to think that which number is suitable for 864. Unit digit is 4. We can easily divide this number again by 2. 2 4s are, 3s are, and 2s are. Again, the unit digit is 2, so 2 2s are, and then 2 1s are, and 2 6s are. Okay, 216. Again, the unit digit is 2, so we can divide that number by 2. Unit digit is 6, even number. So 2 how many times is 21, or closer to that? 2 10s are, and 1 will be given to 16, and 2 8s are. Okay, and then again the unit digit is coming 8, which is even, which is a multiple of 2. So I think, students, what do you say, which table will be suitable? Table of 2. Okay, 2 5s are and 4s are, 2 2s are 4, and 7s are. Okay, now wait and think. Unit digit is not even, not multiple of 2. So which table is suitable for this number? Okay, then after 2, the next prime number is 3. 3 9s are 27, 3 3s are, and 3 1s are. Okay, now we have completed our prime factorization. So first of all, I have to write 1728 as the product of its prime factors. 2 is coming 1 2 3 4 5 6. 2 multiplied by 2, 2 2 1 2 3 4 5 and 6, and 3 is coming how many times? 1 2 and 3 multiplied by 1. Okay, then what we have to do, we have to write these all factors in index notation in short form. 1 2 3 4 5 6. 2 raised to power 6, and 3 is coming 3 times 1728. And now this is not the requirement of question, students. We have to find cube root of this number. So what we'll be doing, we have to write this 3 over here, that is the symbol for cube root, and on the other side as well, 2 raised to power 6 multiplied by 3 cube, and this is cube root. And now for the simplification and calculation purpose, 2 raised to power 6 multiplied by 3 raised to power 3 and whole 1 by 3. Now look, this outside index is the index of every factor inside the bracket. Okay, so what we can do is that we can write it in the form 2 raised to power of 6 multiplied by 1 by 3 times 3 raised to power of 3 multiplied by 1 by 3. This goes, 3 ones are and 3 twos are. 2 square multiplied by 3, which is equal to 4 multiplied by 3, which is equal to 12. So 12 is the number whose cube is 1728. Okay, or the cube root of 1728 is 12. So 1728 cube root will be equal to 12. Again, students, you can observe carefully that if the number is a perfect cube, the index of each prime factor must be either 3 or multiple of 3, so that we can easily simplify them and we can easily take that number out of the square root or cube root symbol without calculator. I hope you are clear about this question, and let's move to question number 4, and let me compare the data with the book. Question 4 says, given that the prime factorization of 9801 is 3 raised to power 4 multiplied by 11 square, we have to find the square root of 9801 without using calculator. Calculator not allowed. So let's think what to do. Okay, students, if we look at the question and the information which is given to us, the half of the working is already done by the examiner, so we are not going to for the prime factorization of this number. The prime factorization with the index notation is already given in the question, and now what we have to do, this is given, must support your working with some statements, some information, so that examiner can understand your message and working easily. And now we have to find the square root. So square root of 9801 equals to, here again we have to put the symbol of the square root, and for calculation purpose what we have to do, we have to write the value of this symbol. Square root is 1 by 2, and now this 1 by 2 is the index of every factor inside the bracket, multiplied by 11 square multiplied by 1 by 2. This goes, 2 ones are and 2 twos are, and we will left with 3 square multiplied by 11, and which is equal to 9 multiplied by 11, and which is equal to 99. You can see, students, that by keeping some rules, basic rules in the mind, we are easily able to find and reach the answer. Okay, and moving to the next question. The next question says that given that the prime factorization of 21,952 is 2 raised to power 6 and 7 raised to power 3, find the cubic root. Find the cubic root of 21,952. Again, really easy question, because it's given that 21,952, the factorization of this is 2 raised to power 6 multiplied by 7 raised to power 3 with index notation. It's already given. It's already given in the question. Half of the working is done, and now what we have to do, we have to find the cube root of 21,952 cube root, and then again here on this side 2 raised to power 6 multiplied by 7 raised to power 3, and this is a cubic root. And for the calculation purpose, I have to turn this power 3 in form of the fraction. This third root, okay, you can read it as third root or cube root, 2 raised to power 6 raised to power 1 by 3 multiplied by 7 cube multiplied by 1 by 3. This goes 2 3 ones are and 3 twos are. 2 square multiplied by 7, which is equal to 4 multiplied by 7, which is equal to 28. So the cube root of 21 952 cube root equals to 28. Students, I hope you are really clear about today's class. In this class, we have learned that how to find the cube roots of the given numbers with the help of prime factorization, and the focus was to observe that if the number is a perfect square or the perfect cube, we have to observe the index of each prime factor carefully. For the number to be a perfect square, the index or the power of every prime factor must be multiple of 2, and for the cube root, the index or power of every prime factor must be multiple of 3. I hope you are clear about today's class. For next difficulty level, please catch me in the next class. Watch my lessons, like, share, subscribe the channel and press bell icon to get the notification of every lesson in time. Thank you very much.